Okay, so that's one of the ways. I mean, this is kind of this will look like something a lot more doable in the time frame that we have, where you just work with one script rather than try to develop something yourself. So working with plugins. So just familiarize yourself with Grasshopper plugins and which ones you can use to interpret which theories, right, and use them. So in terms of coming up with spatial relationships and things not being in the tree, you can use this plugin called Magnetize, or Space Syntax plugin as well. Yeah, you can use those. This is just me showing you how the whole translation thing happens. Okay, so the second part of this I want to show you is iterating through your spatial strategy and through something called genetic algorithms. And this is a lot more simpler than they actually sound, genetic algorithms. It's based on the idea of the theory of random selection through, natural selection through random mutations. Yeah, so the idea that that there's random changes in the gene, and the fitter variations of those genes always survive. Yeah? So it comes from evolution. There. So here, genetic algorithms. First thing, they just have a random population. I'll show you. This will make a lot more sense when I show you the script. So there's a random population, but there's always a fitness calculation. So there's always a number associated with the population in terms of which one is better than the other. Yeah. So this is an example of random population, and the algorithm, what it does, it ranks them in terms of which one is better based on the criteria that you give it, and then just iterates through it. So it goes in a cycle where it just tries different things and always chooses the best genetics and moves them forward. Yeah. And this is what you can see here. So genetic algorithms, what are they good for? So they're good for optimization, rapid iterations, exploring design space of your parameters, and evaluating design. So I know this might not make a lot of sense now, but let me show you another script that I did yesterday. So if I go here, open, this will be a Design Explorer. Hey, this one. No, it's not this one. Where have I saved it? One's in that analysis. I think it's this one. Yes, there is. Okay. I haven't got the prep. Where have I got the one? So if I go on this one, no. So, no, this is not it. Well, actually, it is. Let me get rid of that. So, just want to show you the geometry that I have here. So, where are we? Zoom selected. So this is our site, right? I just imported it so I can use some of the conditions on the site. Basically what I've done is I've just selected this as a volume. Yeah. So let's say this is a volume that I want to develop. Yeah. In my design, and I want to use a genetic algorithm to figure out my design. Genetic algorithms, I said earlier, they're not very complicated in their idea. I'll show you now, and hopefully it makes sense. And again, it uses a plugin in Grasshopper, right? So the plugin here that I've used is called Galapagos. It's native to Grasshopper, so you don't have to download it externally. But I have here as well, there's these two which are more advanced. So there's Octopus and Wallisey. Yeah, so these two also use genetic algorithm. These two are more advanced. The one I'm showing today is the native one, which is considered to be simpler. And this, I'm basically using it to test out different iterations of one thing. Yeah. So don't get overwhelmed with this. It's not really that complicated. So just try starting off with a brep. Yeah, and here all I'm generating is these random volumes. So if I turn off this for a minute, all that this script does is just generate this, basically. So I've just taken circles, and with this idea I was trying to kind of show you how what's the Tio Ito Sendai, I think, Sendai, yeah. So this is a really good case study for you to look at, where Tio Ito, very famous architect, so they looked at light wells and how to integrate them within a building. I don't know if they used any kind of Grasshopper algorithm or any algorithm, but they thought about light wells and them not just being a kind of a boring void, yeah, but actually these wells working as columns and light wells at the same time, and adding this kind of interesting spatial features in between, right? So if you look here, this is what holds up the building, and at the same time lets all the light in. So it's a good case study to kind of look at. And this is the same here in terms of what you can do. So I'm coming up with one of these cylinders. Again, what this script does is just come up with a cylinder, right? It does nothing else. And I've done 3 of them that are slightly different. Yeah. So you can see this was 1, 2, 3. I've copied and pasted all these, but well, you really shouldn't need to, but you can actually work with data trees and create them all in one place. But I just did this because it's easier for you just to look at 3 different things to understand it. Yeah. So I have a brep and I have these 3 volumes. Yeah, that's all what I have at the moment. And basically the challenge for me here is how can I place these within my volume to maximize the amount of light that I'm getting. Yeah. So I mentioned earlier with the genetic algorithms, what they're good at doing is optimizing and iterating. So how can I place these 3 volumes within my overall volume in a way that lets in a maximum amount of light? Yeah, and that's the problem I'm trying to solve here. And you can see this is the geometry that I have at the moment, right? It doesn't. You can see 2 of them overlap. I've got something interesting going on here, but this is not making a lot of sense. Yeah? This, you can use a clipping plane to just look at vertical. So here. Right, so as you can see, it doesn't work well because I have these 2 overlapping each other, right? And I'm not maximizing the amount of light I'm getting in. So this can be applied with any design problem, right? It can apply to the actual overall geometry. So I can apply genetic algorithms to this. Let me delete this so it doesn't confuse you. Genetic algorithm to this volume and actually placing it in a way or in an orientation where it maximizes the amount of views, or the maximizes the amount of sunlight, or maximizes the structure that I have. Yeah. So genetic algorithms are always used to come up with one single best solution for certain parameters that you've designed. Yeah. And the parameters that I've designed here is where can I place these 3 things. And if you see closely here, so let me, oh, that's fine. These are the parameters that I've defined. So if I move these, you can see that the voids are moving, right? So the void right on the top there is moving. You see that one? Let me turn off Weaverbird because this is what's causing disable. So I have this. So these 3 voids, and I control their position with these sliders here. Yeah, so you can see it's moving in different directions. Yeah. So that's one of them. I can move the other one here. And then I can move the other one there. Yeah, so at the moment they're all clashing with each other, but of course that's not what I want to do. And I'm just getting, you see here, I'm just creating a solid difference. So I'm extracting the main, these small, these cylinders here, light wells, from the main brep. Yeah, so that's what I'm doing here. And then coming up with surfaces. Yeah. So let's say these are my floor plates. This is not the best design, but I'm just showing it to demonstrate. Yeah. These are my different floor plates, and these are the voids I want within my floor plate. And then, of course, if you're familiar, Weaverbird, it's one of the tutorials that I gave before we broke up Christmas. So using Weaverbird for sunlight hour analysis. Yeah. So here, basically what this plugin enables me to do is calculate the amount of light diffusion I'm getting within my floor plates. Yeah. So by introducing those voids, you can see I'm getting more light in here. And you can see it's actually, it's not improving massively, but you can see it's actually improving. So rather than blue, which is the no daylight at all, I'm getting more daylight in these lower floor plates here. Yeah, and then if I move these, you can see that the whole thing changes. The whole field, if you like, changes. So you see there, yeah. Yeah. So at the moment, I'm moving those volumes, light wells, and because I've linked it to Weaverbird here, it's doing the analysis in tandem. Yeah. So it's giving me the analysis, and then here, one of the outputs of Weaverbird is total sunlight hours. So you can see here I have 214,000. Now, if I have a different iteration, let's say I want to move this one here, and then I can go and not much has changed. I have 213,000. So my previous iteration was better in terms of sunlight analysis. Yeah. Okay. So this is the outcome I'm getting, total sunlight analysis, and this is my fitness criteria. So I mentioned here in terms of genetic algorithm, it takes a population. So my population is all the variations of the voids within my main mass. These are all, like, every single possibility is my population. Yeah. And the fitness calculation is the amount of sunlight I'm getting. Yeah. So the best version will always be the version I'm getting more sunlight. Yeah. And basically what the genetic algorithm does is just goes through them. It goes through them, tries different genes, which basically means tries to change the sliders. Yeah. So here you can see Galapagos works in a different way. So you actually connect the slider to the left, not to the right. But you can see I've connected the plugin Galapagos to my inputs, which control the positions of the light wells. Yeah. And I've given it the fitness calculation, so total sunlight hours. Yeah. So it knows what to control and change in terms of the position of the light wells. Yeah. So it knows it can. What it can do is iterate through them and say at the end of it, it will give me one and say this one is the best one. Yeah, because I've given it the value for it to compare all the ones together. So hopefully this is making sense. Fitness calculation. That's all you need to know. But if you want to be more kind of specific, what it does, it takes initially it starts very random and then it starts to narrow it down. So based on the group that it created, it'll take the better ones and try to manipulate those rather than trying to manipulate every single possibility, because sometimes the possibilities are endless, right? Sometimes there are too many to consider. But what the genetic algorithm does is it always narrows down. After each iteration, does an iteration, let's say does a batch of 100. Okay, it knows that if they're all closer to each other, it never works. So it looks at the population that where the light wells are further away from each other and takes those and then refines it. Okay, what if I put this right at the extreme corner or this one here? Yeah. So again, the principle is straightforward, right? So you have your parameters. So these are my parameters. So I slide it from 0.3 to 0.8, I think, just because I don't want it to go right to the outside. So I've given it a certain range. I've connected those. So genome here means basically the variation type, and gene means basically the inputs of that variation type. and then my fitness criteria for each one of those. So if I double click here, I get the Galapagos user interface. Yeah, but before I want to do that, I just want to turn this on so we can see what's going on. So if I double click, I go on solvers, I click on this one, use evolutionary solver. Before that, actually, I can go on options. The fitness, I can either try to maximize or minimize. So in my case, I want to maximize the amount of sunlight. Yeah. So I'm doing maximize. Sometimes you want to minimize. So if, let's say you have a circulation and you want to make it, you want to reduce the amount of circulation, you'll minimize. Yeah. So here, minimize. So always look for the smaller fitness score that you give it from here, rather than the big one. Yeah. And then these are the other settings for the solver. These, I think you can start off with the generic ones, but if you need, you can set like a time limit. So it'll only take an hour or whatever. Sometimes it takes more, but it's all about it's worth mentioning here that you can't really give Galapagos a lot of inputs, right? So the less inputs you have here, usually the better. So 6 will be pushing it slightly, I would say, with this. Yeah. And also, of course, because at the beginning it's random and it needs to go through a lot of variations, you shouldn't give it something where you should give it more steps. So here you can see I haven't got 0.006 or 0.621 yeah, because then it'll have to jump incrementally. I've just given it so I've designed the slider so it will be an incremental jump between in 0.1 steps, right? So it'll be either 0.6 or if I move it here it'll be 0.7. Yeah, there won't be any in between because I'm not interested in those in that granularity, right? So making sure the designers are, the sliders are set up in the right way. And then clicking here, I can go in solvers and then start solving. Oh, sorry, that's the wrong one. Stop. We only use this one, the evolutionary start. So so this is actually running, and you can see here that my geometry is actually changing. And what this is doing is Galapagos is trying out different iterations, right? So it's changing the slider around and then recording the fitness, recording the score that I told it to kind of base it on. So you should see this changing every once in a while. Yeah. So still running. Let me just change the settings, maybe it'll be easier. So in a moment, what you should see is some of the data being visualized there in terms of the different iterations that it's going through. But this usually comes up with a kind of graph here showing you the range of sliders chose and the fitness and how it's narrowing down the options. So if I go here, it's very popular. You'll find a lot of resources for Galapagos. But here it's showing me the population here. So the black dots will be the ones that it's chose, and the red dots are the one that it completely ignored because they're not very good. And it always narrows down, as I mentioned earlier. So this is not the best example, but you can see here, it always narrows down. So it knows that there's the direction. So it tries to keep them away from each other as much as possible. And then these genes here, these will be your outcomes at the end. So this will be every iteration. You can actually click on it and get the value of it here. So there might be too many sliders here. So let me do this again, but with just 1 or 2 voids, so I can show you how it works in real time, right? So let me I'll just delete these for now. So I just have 1 now, yeah, one void, and I want to place it in a position that I want to maximize the sunlight, right? So I just have 2 inputs here. Do that again, solver, start solver. No, it's the wrong one. Keep on making the same mistake. Just go here, evolutionary solver, and then start. Hold on a second. Why is this not working properly? Display all geometries in random viewport. Only display better geometries. Let's display all. Display all geometries. Display 50% of genomes. Add additional. That's fine. Okay, so let's start here. So you can see this is actually the speed it's iterating in. Because I have the Weaverbird plugin. The Weaverbird plugin can be heavy sometimes, so that's why it's not being very fast. If I have something else, I need the Weaverbird plugin to calculate the amount of light, right? So that's what it's doing. But this is actually the speed it's doing. So it's taking those two sliders and changing them around, and then I'm getting this feedback here. So it does it in bunches. So it does 100, and then it gives you the results, and then it does another 100, and gives you the results. Yeah, we can leave this running just for a couple of minutes because I want to show you this outcome right here. Okay, has anyone got any questions about what I've shown you so far? Do you feel like this is easy? Do you feel more overwhelmed? Anything, I just want to hear anything from you guys.
I think Kareem has some questions.
Rude, Jordan. Rude.
I'm just kidding.
Yeah. I think you both have questions. What's your question, Jordan?
No, I don't have one.
No? Do you think it's too easy, right? Nothing.
No, I wouldn't say it's too easy.
Is there anything not clear? That's why I want to make sure that you're all clear and there's nothing I missed out or nothing that you didn't understand completely. So you can move forward. So if there's anything, by the way, like this is the first time some of you would use genetic algorithms or try to develop kind of computational scripts. So any questions really, it's better than not answering questions and then trying to figure out. Yeah. You can see here, right? Some of the app. Oh, what's happened? It's just gone. I don't know why it vanished. Giuseppe, do you want to add anything? Since no one wants to. Since
yeah,
I'm just by myself.
I was thinking maybe if can you hear me?
Yeah, I can hear you.
Yeah, I was just saying maybe you have in options it's not on the options of visualizing the updates. That's why you don't see it. Have you checked there? Maybe.
The options. No, it came up now. I don't know why it just.
Okay.
Options. Strange. I don't know. It just it's coming out.
Yeah, there is. It's just a bit slow, basically.
Yeah, it's just a bit slow. I think I didn't click on it. But you see, okay, so you can see here now. So this is actually quite interesting to unpack here, yeah? Again, I mentioned it's slow. It's not because of the Galapagos plugin. Galapagos plugin works quite well. It's just because at every single stage, Weaverbird needs to calculate all the sunlight exposure and the different flow levels, etc. So that's why it's taking a long time. But you can see here, these are the different populations. Yep. And because I've set the sliders to increments of 0.1, you can see that the populations are kind of clustered together. This doesn't usually happen, but in this case it does because I'm giving it certain increments to work with. And here on the left, here on the right, sorry, you can see there's two light green, and here's dark green. And this tells me that there's two inputs, which I've given it in terms of the position of this, right? Remember, there was two sliders that dictate the position. So it's telling me there's two inputs, and how wide it is just shows me the value that I've used. Yeah. And once I click on it, actually tells me these are the different values here. Now, if I have 3, this will actually be a bigger graph. But this is the first value, so it'll be 0.3, 0.4, 5, 6, 7, and the same here. So with this instance, it actually had a 0.4 input and a 0.3, 4, 5, 6. 0.6 in the x and 0.6 in the y, and this is the outcome that I get. The overall sunlight exposure is 21, 216,000 there, yeah? Sunlight hours across the year. You see here, these are becoming very similar, right? Yeah. Actually, yeah, but it's ranking them in terms of the best. So this will be the best because I have the bigger number. And then if I go down, it's ranking them in terms of the worst. So this is the worst outcome that I can get. Now, I don't want to stop this right now, but if I press reinstate, so if I click on the best solution or any of the other solutions and press reinstate, it'll actually take me to the one that I've chose here. Yeah. And it can also kind of look at the different stages of its development and see which ones worked out. So I think Galapagos is a good way for you to get started, actually. Test it out and see how it works. I think what we'll do is we'll do a quick exercise of a simple Galapagos plugin kind of exercise, just so you know how it works, and then we can move on. But this is the outcome, right? And I'm not sure I've uploaded this to the Grasshopper library, but I'll check and I'll upload it if it's not there. Okay, so I want to stop this now.